In this video, we will be answering numbers 8, 9, and 10. These questions are under the lesson about torque. Yeah, these will be the hardest questions that we'll be answering regarding the said lesson. So let's start. For number 8, an 8-meter ladder with a weight of 335. Okay, I'll cut you. Let's just get to the listing of the values. You don't have to read everything. An 8-meter ladder. So regarding the ladder itself, we know that the length is 8 meters. So where is this ladder headed? So let's say this is the wall, right? So this is the ladder. If there is no wall, then naturally the ladder will move this way, which is considered clockwise. Therefore, the ladder, let's say the ladder is the D1 and the weight is weight 1. So distance is 8 meters, weight is 335 newtons. So, a man weighing 875 newtons stands on the ladder. So, given that the ladder and the person, they basically have the same direction. So if the ladder is already able to fall by itself in this direction, the person can intensify this motion since he or she is located on the ladder itself. So D2, weight 2 is 875 newtons. How about distance 2? 630 meters, 6.30 or 6.3. So that's it. How about D3 and W3? What is that in the first place? Well, okay. It says here, a ladder lies at a 50-degree angle, which is this, above the horizontal. By the way, in this kind of scenario, we will be involving angles. We know that this is 90 degrees. This is 50. Therefore, this one is 40 degrees. There's a property that states that the sum of interior angles in a right triangle amounts to 180 degrees. So, given that these are 50 and 90, 180 minus the sum of these two equals to 40. So, after that, we have to look for the angle corresponding to the ladder. So, angle 1 or angle theta 1, whatever is appropriate, whatever suits you. So angle theta 1 is what? So this is the ladder, right? It's said to be 40 degrees. And the human also has the same angle, 40 degrees, for a reason. I'm just not sure what that reason is. But one thing that you can always remember, this is a pattern that you can observe for the following questions that we'll be answering. So let's say this is the ladder, and this is a human. Their motion is the same. Their direction is clockwise. And how do you determine the angle? Whether it's this one or this one? Well, it's always going to be this, provided that the direction is closer to it. If we say it's this one, it's farther from the direction. What I just said isn't exactly proven to be a rule in physics, but sometimes you just gotta make observations if you're not sure about why things are like this. But surely, my solution is based on answer key. So, yeah. Again, know that this is the angle for the torque of clockwise in the context of this question. So counterclockwise, we have the wall itself, since that's what counters the ladder from actually, and the human, from actually moving this direction. So we have D3. What is the height of the ladder? And what is the force the wall exerts on the ladder? So F3 is missing. D3, how do we determine D3? Actually, the height of the wall is supposed to be taller. Actually, no. Well, yes, actually, yes. This is supposed to be 8 meters. And this is supposed to be 4 meters. There has to be a reason why it's written that way. Well, for one reason, so we know that D3, this is 8 meters. No. That's not what I mean. Let's go with this one first. D1 is equal to 4 meters. Why? Again, these values correspond to the ladder. These correspond to the person. These correspond to the wall. So for the ladder, it's said to be here. So yeah, this is the distance of the ladder. So if, let's say this is 4, the other half is going to be 4 also. So in total, the entire thing is 8. But yeah, there has to be a reason why, even though the ladder is said to be 8 meters, the weight is focused at the center. And there has to be a reason why it's 4 meters instead. And we have the force of the ladder, or the weight, 335 newtons, situated in the middle. So yeah, can make sense, I hope. And here, it's a little farther from the half. So let's say this is 6.3 meters. And yes, the entire thing is 8. Now, we know that for the ladder and the person, both of them move clockwise, and their angle is 40 degrees. On the contrary, our angle for the wall itself, or the force that opposes these two, it's gonna be 50 degrees. Okay, so now that we have the values, let's put them in this equation. So TCC F3 D3 sine theta 3 is equal to F1 D1. Again, F and W could be used interchangeably. Sine theta 1 plus F2 D2 sine theta 2. So what is F3? That is what's missing. D3 is 8 meters. Sine theta 3 is 50 degrees. F1 is what? 335 newtons. D1 is 4 meters. Sine theta 1 is 40 degrees. F2 is, or W2 is 875 newtons. D is 6.3 meters. Sine 40 degrees. Okay. F3 is equal to all of these divided by this. Alright, so what is the answer? If you have your calculators with you, it's going to be important. The answer is 718.7413 newtons. Okay, that's it for number 8. So, solving these kinds of questions, the strategy may be kind of unfamiliar in the first place, but as long as you practice more of questions similar to this one, you'll eventually get the hang of it, and you'll understand why this is like that, basically. What's wrong with this guy? Anyways, the foot of a ladder. Okay, let's write TCC and TC first. Again, I forgot to write it in the previous question, just to make sure it's repeated every time and eventually one will memorize it. The foot of the ladder rests against a wall, stop held by a tie rope. Okay, so this is the foot of a ladder, rests against the wall, stop is held by a tie rope. Okay. The ladder weighs 100 newtons. So where is the ladder headed? So if there's no rope, it would eventually move this direction, which is clockwise. So let's say the ladder's weight is, it corresponds to W1. So 100 newtons. What's the distance of the ladder to the center of gravity? So as you can see here, this is the ladder's weight, and this is the distance to the foot. How do we identify the distance? Okay, the center of gravity is 0.40 of its length. Okay, I think this is the length itself. So 0.40 L from the foot. It makes sense because when we say center of gravity, that corresponds to the ladder or the stick itself or the ruler. Regardless of the situation, it's always going to be whatever is being balanced, is involved in being in an attempt to balance everything to make T net equal to 0 Newton meters. In this context, it's a ladder. So next, a 150 Newton child hangs from a rung that is 0.20 of the length from the top. Okay, so length from the top 0.20. So I'm starting to think this is one length, which is I think it's already implied, unless stated otherwise, of course. So this is a child. It's going also in the same direction as the ladder, should the rope be not be there. So the child will fall. And with respect to a pivot, it will move like this too. So let's say the child is going to be, hang on. So this is the ladder. This is going to be the child. W2 is 150 newtons. D2 is what? So this is where it gets interesting. So if this is 0.20 and this is 1, then 1 minus 0.20, that's going to be 0.80. So coming from the pivot, of course, as well, it's going to be the distance that we'll be looking for. The distance of the object or the child or the ladder to the pivot. It will always be to or from the pivot. You can't measure a distance, for instance, like this. It's not 0.20 since it has no association with the pivot. If you get what I mean. So, anyways, here we have 90 degrees. So 180 plus, 180 minus 90, 90 minus 37, that is equal to what? 53 degrees. Okay. Here, how do we determine the angle for the ladder and the child? Supposedly it's they ought to be the same since their direction is the same. They're both under clockwise. So let's go back to number 8. We know that it's 40 degrees for the clockwise here because, well, for what reason? Perhaps, hang on. We have to look for the pivot first. Did it state? Perhaps it's this one. There's no rope in this context, in the context of number 8. Okay. Doesn't really add up. Doesn't really make sense, but perhaps for the ladder and the child, the angle that we'll be using is the angle associated with the pivot itself. And the rope will be associated with 50 degrees, which is supposed to be the torque counterclockwise. So W3, okay, so determine the tension in the tie rope. I suppose the tension that is meant here is this one. Yeah, W3. Since it's the, like, it's a total tension that is constituted by the ladder and the child against the tie rope. So let's find D3. D3 is what? I suppose that's going to be the one length. It ought to be the total of everything. So yeah, so far so good. W3. Yeah, that's missing. TCC is equal to TC. Just to let you know, determine the tension in the tie rope. That's not that does not mean that we have to look for the total torque or the net torque. So TCC, W3, D3, sine what? Oh yeah, I almost forgot the angles. Angle 1, angle 2, angle 3. For angle 1, we have 37 degrees. And for the rope itself, which is supposed to be counterclockwise, we need 53 degrees for that. So, what's next? Yeah, right. Back to where we left a while ago. Okay. Now what? Weight 3 is missing, right? D3 is 1 liter. 1 length. Sine 53 degrees. W1 is what? 100 newtons. D1 is 0.40 length. And then sine 37 degrees. And then W2, that's 150 newtons. 0.80 length. And sine 37 degrees. W3 is equal to all of this divided by this. So we have 120.569 newtons. Or yes, if we convert it, round it off to the nearest whole number, it's 121. But yeah, the answer is roughly the same. Okay, last question, number 10. So the given triangle plate is fixed from the point O and can rotate around this point. Find the total torque given by given forces. Okay, let's enlist TCC and TC. Be right back for 10 seconds. Okay, where are we? Just to let you know, when I first tried to answer this question, I didn't understand the point of having these two. I thought it was contradictory to what I was taught to understand. Since counterclockwise is this direction, then it's supposed to be positive. But here, why is it negative? And that also goes for clockwise. If it's supposed to go this direction, why is it positive? So yeah, I wasn't really able to clarify that to the teacher. They seldom reply on Google Chat, so if they reply at all. So yeah, we're on our own with this in this one. So force 2, force 1, force 3. Force 1 is obviously going to be useless. It won't be the torque clockwise or counterclockwise, since the force is literally going towards the pivot. It's not going to change anything. So yeah. By the way, if there are no angles stated, although yes, it is recognized that this kind of triangle, even if we don't have the values of this and this, it is implied, and you have to memorize that. You have to memorize those degree values, but here you don't really need to. A classmate of mine tried to search, and he used sine theta, like torque is equal to FD sine theta, and yeah, his answer was also the same as this, and we don't have to do that. So yeah, we'll be solving the easy way, the normal way, the generic way. So this force F2 is going this direction, which is counterclockwise. So F2 is equal to 4F. How about the distance of F2? So it's said to be 2D. And the force of F3, on the contrary, is this direction, which is clockwise. So F3 is equal to 6F. D3 is equal to what? I know it's this, 5D, but based on the answer key, it's said to be different. Yeah, I think my teacher made a mistake in the answer key, since according to him, the D3 is equal to 4D. But where in tarnation will you be able to find 4D in this illustration? Okay, moving on. Yeah, I believe it's 5D. Wait. maybe he has a point, and it's a valid point, which registers my reason invalid. So I think this is his logic. Why is it 4D in the first place? Well, you don't measure the distance with this. You measure the distance only through this, the arm that's connected to the pivot. So let's say F1 is 5F, right? And the distance, it's the force one is over here. So the distance is 4D. And for F2, the distance is 2D since F2 is here. And F3 is here. We don't identify the distance through this. We identify it through this. Since F1 and F3 are at the same level. Say this is a Cartesian plane. They're on the same y level. So yeah, D3, the angle, wait, we don't need the angle pala. Yeah, that's it. F1, again, we don't need that. I'll just write it here. Why is it useless in the first place? Again, aside from the reason that it goes towards the pivot itself, like literally, the angle is going to be the reason why it's equal to 0. So let's say the angle is 180 degrees or 0 degrees. The answer is still going to be 0, either way. In this case, let's say F2 is this, F3 is that, F1 is this, 180 or 0 degrees. F1 is 5F, right? The distance is 4D, the same as the distance 3 or D3. If you put it in your calculator, this one, FD sine theta, right? 5F times 4D sine 180 degrees or sine 0 degrees, that will amount to 0. So yeah, it's no longer mandatory to add that in the equation that you ought to find the final answer from. So TCC is equal to TC, F2D2 is equal to F3D3. Hang on, what are we looking for in the first place? Find the total torque. Okay, makes sense. This is not a formula that we're supposed to use. Rather, it's this. T net. Always don't forget the minus sign right there. And yes, we're always supposed to assume that the T net in this context is 0. Unless it's stated otherwise. So far, our teacher did not give us a scenario where the T net is not equal to 0. Everything is balanced so far in the questions that we have answered. So if you're looking for practice questions that are answered, practice questions that involve the T net being not equal to 0, then there are many videos out there. But this one's based on what I've learned in class. As much as I want to expand from the basics, I can't do that on my own. It's a school's responsibility. But yeah, we're in the Philippines. What do you expect? Quality education's out there, not here. Although yes, you're lying if you say that the Philippines isn't improving. Yes, there's improvement, but it's still gonna be a long time until that actually is felt by everyone. Anyways, back to where we are. Uh, Wait, no. Sorry. Uh, T-net in this context, that's what we were looking for. So it was definitely not equal to 0, right? So this is what we have. Why is it negative in the first place? What does it mean if the answer is negative? That means we all know that TCC is positive, right? And TC is negative. Well, if your answer is negative, then that means the force that's dominant is, since it's negative, it's clockwise. So we can also say, as in our final answer, the torque is 16 FD. We don't have to write the negative sign, but instead of writing the negative sign, we write what it corresponds to, which is clockwise. So there are no negative values. For instance, in acceleration, we know that if the acceleration value is negative, then it's supposed to correspond to deceleration, or the decreasing in acceleration. So yeah, it's not necessarily a negative value, it just represents the opposite of what's usually associated with the positive symbol. Here, the positive corresponds to counterclockwise and the negative for clockwise. In acceleration, positive is acceleration itself, negative is deceleration. So yeah, that's it for this video. Yeah, thanks for watching.